Warm-blooded and means their body temperature does not change according to surrounding. Their body temperature is fixed. Likewise ours. And their body is covered with hairs. They have limbs for locomotion. Limbs yani ki khutta bhaneko. But in the water, living mammals, the limbs are modified into paddles for swimming. Likewise in dolphin and whales, they do not have limbs. They have paddles, fins. Some examples of mammals are human beings, rat, cat, dog, bat, whale, dolphin, hippo, etc. Okay. What is mammalia? Mammalia is a class of vertebrates which includes the animals having mammary glands in the females and give direct birth to their young ones. क्लास मेमोलियामा पर्ने जति पनि अर्गानिजम्सहरु छ सबैले बच्चा जन्माउँछन्. अंडा पार्दैन नै बच्चा जन्माउँछन्. This is the specific characteristics of mammalia. What are the characteristics of mammalia? The characteristics of mammalia are: the body of mammals is divided into head, neck, trunk and tail. Most of the mammals live on land while a few live in water. They are warm-blooded animals and their body is covered with hairs. They have limbs for locomotion. एक ठाउँबाट अर्को ठाउँ हिड्नका लागि चाहिँ खुट्टा हुन्छ. But in water living mammals, the limbs are modified into paddles for swimming. What are the examples of mammals? The examples of mammals are human beings, rat, cat, dog, bat, whale, dolphin, hippo. Now, there are some of the points about the different class. Okay. Once again, how many classes of vertebrates are there? There are 5 classes of vertebrates. What are the different classes of vertebrates? The different classes of vertebrates are Pisces, Amphibia, Reptilia, Apes, Mammalia. What is Pisces? Pisces is a class of vertebrates which includes different types of fishes which breathe through gills and have fins for swimming. For example, shark, seahorse, carp, rayfish, etc. What is Amphibia? Amphibia is a class of vertebrates which includes those vertebrates which can live both in water and on land. For example, frog, toad, salamander, etc. What is Reptilia? Reptilia is a class of vertebrates which includes cold-blooded crawling animals. For example, snake, crocodile, turtle, lizard, etc. What is apes? Apes is a class of vertebrates which consist of birds which have strong wings for flight. For example, pigeon, hen, sparrow, parrot, etc. What is Mammalia? Mammalia is a class of vertebrates which includes the animals having mammary glands in the females and give direct birth to their young ones. For example, human being, rat, cat, dog, whale, dolphin. Once again, what is vertebrates? Vertebrates are those animals which have backbone in their body. For example, human beings, frog, fish, birds, etc. Let's learn something more about the different classes of vertebrates. You know, fishes have 2 chambers in their heart. माछाको मुटुमा चाहिँ 2टा कोठा हुन्छ अरे. 2 chambers. Amphibia. Fishes and amphibia show external fertilization. External fertilization means the fertilization that takes place outside the female body. What I mean is the fusion of male and female gametes takes place outside the female body. It takes place in water. Amphibia and reptiles have 3 chambers in their heart, whereas apes and mammals have 4 chambers in their heart. Reptiles, apes and mammalia show internal fertilization. It means that fusion of sperm and ovum takes place inside the female body. Mammals are viviparous. Viviparous means they give direct birth to their young ones. Bat is a flying mammal because it gives direct birth to the young ones. Bat यानी कि चमेरा. चमेरा पनि mammals हो है. किन त भन्दाखेरि किनकि यसले because it gives direct birth to the young ones. चमेराले अंडा पार्दैन. चमेराले डाइरेक्ट आफ्नो बच्चालाई बर्थ दिन्छ, जन्माउँछ. Okay, these are the things you need to read in this chapter. Now you can do some activities work. You can observe in your surrounding and list any 5 animals of each class. Observe the animals. You can see different kinds of animals in your surrounding. Observe 5 animals that comes under pieces. Write its name and draw the figure. Observe 5 animals that belongs to class Amphibia. Write its name, draw its figure, label its parts. Observe 5 animals that belongs to Reptilia like lizard, snake. Just observe. Write in your copy, draw its figure and learn about it. List 5 animals that belongs to apes like pigeon, hen, parrot, etc. Write in your copy, observe about it, draw the figures. Also list the 5 animals belonging to class Mammalia. List in your copy, draw the figures and observe about them. In conclusion, let me conclude both unit 1 and unit 2 once again. Invertebrates are those animals which do not have backbone in their body. For example, amoeba, hydra, octopus, butterfly, etc. Vertebrates are those organisms which have backbone in their body. For example, human being, pigeon, snake, lizard, frog, etc. Invertebrates are classified into 9 different phylums, whereas vertebrates are classified into 5 different classes. The 9 different phylums of invertebrates are: number 1, Protozoa, number 2, Porifera, number 3, Coelenterata, number 4, Platyhelminthes, number 5, Nemathelminthes, number 6, Annelida, number 7, Arthropoda, number 8, Mollusca, and number 9, Echinodermata. The 5 different classes of vertebrates are fishes, Amphibia, Reptilia, apes, and Mammalia. Some key terms: oviparous means those animals which lay eggs like birds, fishes. Viviparous means those animals which give direct birth to their young ones like us, human beings. In the next class we will study about cell. If you have any confusion regarding this lesson, you can call or comment in the Facebook page of Radio Sathi. And that's all for today. Stay home, stay safe.
भाइ बहिनीहरूलाई फेरि स्वागत छ कार्यक्रम रेडियो स्कुलमा। तपाईहरूले भर्खरै कक्षा 5 र 6 का लागि तयार पारिएको कक्षा सुनिसक्नु भएको छ। कक्षा सुनिसकेपछि तपाईका केही प्रश्न वा जिज्ञासा भएमा रेडियो साथीको फोन नम्बर 023 563 037 मा फोन गरेर प्रश्न टिपाउन सक्नुहुनेछ वा हाम्रो फेसबुक पेजमा समेत प्रश्नहरू पठाउन सक्नुहुनेछ। अर्को कक्षामा भाइ बहिनीहरूको जिज्ञासाको समाधान गर्ने प्रयास गरिनेछ। अबको पालोमा कक्षा 7 र 8 का भाइ बहिनीहरूका लागि तयार पारिएको कक्षाहरू सञ्चालन गर्दै कक्षा 7 र 8 का विद्यार्थी भाइ बहिनीहरू कापी कलम लिएर तयार रहनुहोस् है त।
Namaste and welcome to you all in this radio school program conducted by Radio Sathi 98.6 MHz. Today, myself, Krishna Prasad Pokhrel from Mechinagar 6 is here speaking with you all regarding the subject of class 7, that is science, and I am here in the lesson number 2, that is force and motion. Okay, dear students, in our previous class we have learned about the force and motion. We have learned about the definition of force, and in the definition of force we have stated force like this. Okay, in this way we have stated force that force is an external agent which changes or tends to change the state, that is position of a body. Its SI unit is Newton. The SI unit of a force is known as a Newton. And I told you in my previous class that whenever we exert a force in any kind of substances, then either it moves or it tends to move. Suppose whenever you are pushing any kind of object in the table, or if any book is there in the table, whenever you push that book, then the force is applied from your arms to the book, and book is able to move on that table. But with the same arms, if you apply a force to push a wall of your room, then are you able to push that wall of the room? No, because room wall is a strong thing, and our hand force, the force which is applied from our hand, is unable to move the wall of the room, because the force which we are exerting from our hand is insufficient for a wall to move. That means one thing we come here to understand, that if a force is sufficient to do work, then only the work done can be seen. Otherwise, without by applying force also, we can say that in some cases there is no any work done. About this term work, I will introduce you later, but force and work, they go in the parallel way, because whenever we apply force, then there is the work done. Okay, let's be clear this much. And I have told you about the definition of force once again, about its application. Now I want to take you towards the effect of force. Effect. I hope that you know this kind of word, effect. Effect of force. Force ले पार्ने असर भन्छौं हामी यसलाई. Effect of force. Now, what kind of effect does a force create on any kind of body? Let's think for a while, dear students. Okay, the number one here is force can change the position of a body. Yes, force can change the position of a body. Let us take the same example which I talked here before some time over here. Force can change the position of a body. I told you to try to move the book which is on the table, then your force is able to move this book. That means book is a body and you are applying force from your hand, then such force is able to change the position of a body. That is the change, you are able to change the position of a book. Next is force can change the speed of a body. Suppose if the body is moving in a low speed, then whenever you push the body from behind, then what happens? The body moves in the greater speed than the speed it was moving before. That means force can change the speed of a moving body. After that, let's learn about the one effect more. Force can change the direction of a moving body. Suppose, for this, let us take one example. How force can change the direction of a body. Suppose you are in the football ground playing a football. That means now you are passing ball from one place to the other. Whenever your opponent or whenever your own teammate, let's call your own teammate, whenever they pass the ball to you, then whenever they pass the ball, then the ball will come in one direction up to you, and whenever you want to pass immediately to the other player by your one kick, then you can directly change that the direction of a ball by applying force from your leg, such that we can agree with this effect of force, that force can change the direction of a moving body. Yes. Now, one more thing I am telling you about the effect of force, that is number 4 is force can change the shape or size of an object. Force can change the shape and size, okay, not or. Force can change the shape and size of an object. The question is now how force can change the shape and size of an object. Let us take one example. You have bought one piece of lemon from the shop nearby your house, and whenever you want to squeeze that lemon, at first you will cut it by applying force, and after that whenever you want to squeeze that lemon, then what happened? At first the lemon was in the spherical form. Whenever you cut that lemon, then it converts into two half of that sphere, and after that whenever you squeeze by applying force from your hand, then the shape of that lemon, the size of that lemon will be changed. Yes, it will be changed. That means force can change the shape and size of an object. Okay, up to here I have done a little bit revision of our previous class. I hope that you all are clear about it and there is no any confusion up to you till the definition of force and till the effect of a force. Now, in today's class, I would like to take you a little bit further about the types of force. Okay, here I can see many types of force is there. But let us introduce the first type, that is the centripetal force. Okay, what kind of force is a centripetal force? Any idea, students, about a centripetal force? Okay, I want to give one example. Whenever you want to rotate anything by attaching with a string, then what happen? You will raise your hand, you will rotate it in the circular motion by carrying a string or carrying a rope with your hand. Okay, suppose whenever you want to rotate a piece of rope, suppose while playing, you have done before, I hope so, you have done before, while playing you have rotated that string, or whenever you have rotated that rope, then as soon as you leave that rope, then the rope goes far away from you. But without leaving, when it was in the circular motion, then the force, obviously the rope tries to go out, because there I have given one example. Whenever you leave that thread, or whenever you leave that rope, okay, from your hand, then the rope goes to the other direction, because the moving rope in a circular direction tries to go outward from the circle. But what force is keeping that rope in the circular direction? That is the force which you apply from your hand. Okay, the force which you apply from your hand while moving rope in a circular direction to keep it constant in the moving position in a circle, that force is known as a centripetal force. Now, one more thing I want to tell you about this. It is also known as a center seeking force. Okay, CENTER, center, SEEKING, seeking force, center seeking force. That means the force which acts towards the center is known as a centripetal force. Okay, now I would like to request you to write the definition of the centripetal force. Okay, I want to start the definition for centripetal force. Whenever an object moves in a circular path, then the force which acts on the center of circular path to keep the body in circular motion, is known as centripetal force. Give a full stop, my dear students. Okay, now till then we are clear about this centripetal force. If not clear, then one more time I want to explain in the Nepali, because while explaining, all the students will not be familiar for the English word. So I would like to tell something in Nepali also about this centripetal force. हामीले जहिले पनि कुनै एउटा डोरीमा अगाडिपट्टि एउटा कुनै भारी अब्जेक्ट लगाएर घुमाउन खोज्यौं भने हाम्रो हातबाट डोरी छोड्ने बित्तिकै बाहिरतिर अब्जेक्ट जान थाल्छ। त्यो सर्कुलर मोसनबाट अब्जेक्ट बाहिरतिर जान थाल्छ र त्यसलाई रोकेर चाहिँ कुन फोर्सले राखेको थियो, त्यो बाहिर जान पनि एउटा फोर्स छ। त्यसको कुरा अब पछाडी आउँछ यहाँनेरि। आई विल टक अबाउट that force later over here. Now, what keeps the object in a circular motion? The balance of two outward and inward force keeps the object in a motion. Because in a circular motion, to be in a circular motion, कुनै पनि object circular motion मा रहिरहनको लागि त्यसले बाहिरपट्टि exert गर्ने force र त्यसलाई हामीले apply गर्ने force भित्रबाट लगाएको force चाहिँ बराबर हुनुपर्छ। Yes, बराबर हुनुपर्छ। And then only the object remains in a circular motion. So त्यो फोर्स जुन हामीले आफ्नो हातले भित्रपट्टि त्यो अब्जेक्टलाई तान्दै घुमाउनको लागि लगाएको फोर्सलाई नै हामी सेन्ट्रिपिटल फोर्स भन्ने गर्छौं। Yes, we define a centripetal force by this way, by applying the force which is applied by your hand, by our hand, or the force which is acting towards the center of a circle is known as a centripetal force. Okay, now let us go to the types of force, that is type number 2, that is called a gravitational force. Okay, whenever you leave any object by raising it to the certain height, then what happens, student? The object falls down in the floor or falls down on the ground. Yes, we all feel this kind of things, and we all know that when Sir Isaac Newton was sitting under an apple tree, then the apple from the tree the apple gets detached from the tree and hits on the Newton's head. Okay, we call Sir Isaac Newton as the father of physics also. This is one additional information to you. We call Sir Isaac Newton as a father of physics, which is the branch of science. We are reading physics, and force and motion comes under physics. Okay, now the such force which is acted between any two huge mass. Suppose the apple is falling towards the earth's surface, because earth is a huge mass. The definition of mass I told you before. Earth is a huge mass and apple is a small mass, and the force between these two mass, due to which the apple falls down to the earth, because earth is attracting each and every other objects towards it. Such force by which earth attract, or in place of earth we can say any other massively large object, that means the object which have the larger mass apply an object which have a larger mass exert force on other object. The such force between the two object is known as a gravitational force. Okay, the such force between two object is known as a gravitational force. Now please write down the definition of this gravitational force. It is the force with which earth or any other massively large object, massively, massively large object attracts another objects towards it. Give a full stop. Okay, this is the definition for the gravitational force, and below that you write down gravitational force, that is represented by F, okay, equals to m multiply g. Okay, we call this as a force of gravity also. And acceleration due to gravity, that g which you have written, m multiply g, that g is acceleration due to gravity, that is 9.8 meter per second square for our earth. It depends upon the mass of an object. For moon the acceleration due to gravity is other, and for earth the acceleration due to gravity is 9.8 meter per second square. Now I hope you are clear about the gravitational force. Any force which attract between any two massively large object, such force is called gravitational force. And due to gravitational force, whenever you drop a pen from a certain height, whenever you drop your sharpener, eraser or any kind of material from the certain height, then obviously it goes towards the earth, that is towards any other massively large object. Okay, this force is known as a gravitational force. Next is magnetic force. Magnetic force, the word magnetic comes from a magnet. Yes, here the force is exerted from a magnet. My dear students, I hope you have seen magnet. Magnet have two different poles. Okay, on the end of magnet there are two different poles, that is north pole and a south pole. If there is north pole in one end, then obviously in other end there will be south pole. Okay, there are two different poles in the magnet, and we have seen that whenever you take a piece of iron nail near the magnet, then iron nail is attracted by a magnet. Magnet tries to attract iron nail towards itself. Why does a magnet attract iron nail? There should be some force in magnet now. Yes or no? There should be some force in the magnet. Then such force is only attracting such iron nail towards a magnet. The force in magnet is known as a magnetic force. I will give one more example. not only the force which a magnet attracts a magnetic substance, that is not only the definition of magnetic force, but you can see that whenever you bring any two like poles or any two same poles nearby the magnet, suppose whenever you bring north pole near, then what happens? If there is any like pole, then magnet tries to push that poles away from itself. That is, magnet repels each other whenever there is a like pole between them. Suppose whenever you bring north pole near to another north pole in any two magnet, then what happens? One north pole from a magnet tries to push away the other north pole from the other magnet. That means whenever there is a north like pole, then like pole means same pole, then the magnet tries to repel. Repel means to push away. Okay, whenever like poles always repel. Just keep this thing in your mind. Like poles repel in a magnet. Okay, there is a question now, what happen when the poles is unlike? Suppose whenever you bring a south pole near the north pole in a magnet, then the magnet tries to attract the other south pole towards itself. That is, whenever there is the opposite pole in a magnet, then there is the force of attraction between the two poles. Such force of attraction is also known as a magnetic force. Okay, I hope you are clear about it. Okay, please write the definition for the magnetic force. A magnet can attract all the magnetic substances like iron, cobalt, nickel, etc. towards it, give a comma, such force exerted by magnet on magnetic substances is known as a magnetic force. Give a full stop. Okay, I told you that not only in magnetic substance but magnet exert force in other magnet also. Okay, such force is called a magnetic force. Okay, and please write down as a note, NOTE note, like poles repel and REPEL repel and unlike poles attract each other in a magnet. Like poles repel and unlike poles attract each other in a magnet. Okay, I hope till then you are clear about centripetal force, gravitational force, magnetic force. Now let us go to the new force, that is the electrostatic force. Okay, what do you mean by electrostatic force? Okay, whenever there is a charged body, now how does the body will be charged? I have taken here a new thing, that is a charged body. Whenever you take a scale and rub it on your head, here, okay, whenever you take a scale and rub it on your hair, on the head, okay, then the scale gets charged because there is a frictional force between the hair and the scale. Then the scale will get some kind of charge, and whenever it is taken to the piece of paper, then there is the opposite charge to that of the charge in the scale. Suppose in scale, if there is positive charge, then on that paper there are both positive and negative charge. Now we have already seen that like poles repel and unlike poles attract in the magnet, but here also same thing. If same charge, then they tries to repel. If there is opposite charge, then they like to attract. Suppose if there is positive and positive charge brought near to each other, then that will be repel. If there is negative and negative charge brought near to each other, that will be repel. But in place of this, if there is positive and negative charge brought near to each other, then that force is known as the attracting force. Okay, the force will be attracted. Okay, I was in one example. Whenever you took one scale, and rub it on your hair, then the scale gets positive charge. And whenever you tear a paper in the small pieces, and whenever you try to take the scale near to that paper, then from that paper the negative charge comes nearby, because in your scale there is positive charge, in paper there is both charge here and there. Whenever you take the scale near to that paper, then all the negative charge of that paper will come in one side near to that positive charge, and the paper tries to be attracted to that scale. I hope you have seen this. Okay. This force is known as the electrostatic force. Same thing. Because whenever there is charge, then the word comes here electric. Okay, because in electric current also there are some charges, positive charge, negative charge. Okay, you have heard this, because these are the common things which we listen in every day. Okay, or in some period of time we can listen about this in our classroom also, in your previous class 7, 6. Okay. Now let's write about the definition of electrostatic force. Electrostatic force is the force exerted by a charged body. I repeat once. Electrostatic force is the force exerted by a charged body on another charged or uncharged body. On another charged or uncharged body is known as a electrostatic force. Okay, we have a little time left. Okay, one more force we want to define over here, that is a frictional force. What do you mean by a frictional force? Let's write the definition for these students at first, because we have a little time left, and after that I will give you some question of today's class. The opposing force, OPPOSING, opposing force, which is developed when a body tries to move over another body, is known as a frictional force. Suppose let's talk with one example. Okay, with the same book which we have taken as an example before. Whenever you apply a little force to push that book, suppose you please try by listening to this radio. Whenever there is a book in the table, whenever you apply a very little force, then does the book moves? No. Because what is the where the force is wasted, where your applying force is wasted? You think that you are applying force from your hand. Okay, तिमीहरूले हातबाट फोर्स चाहिँ अलिकति बुकलाई लगाइरहेको छ, आफूलाई फिल भएको छ मैले बुकमा चाहिँ फोर्स हल्का रूपमा लगाइरहेको छु. You also feel from your side. I'm feeling that I'm applying some little amount of force to move this book. Why this book is not moving? It is so because there is some other force which tries to stop this book from moving. Okay, that is opposing force, the force which is coming from the opposite side to stop my applying force to stop the book from moving. That is called a frictional force. Okay, because book is attached to the table. Okay, book surface area is more, so more space is occupied on this table. So whenever more space is occupied in this table is not a smooth surface. Table is not a smooth surface, so there is the more amount of frictional force in this book. What even if you fix a wheel in any kind of bigger load, then it will be easy to push it, because the wheel exert less area on the surface, so that if the less area is there, then the frictional force is less, then opposing force is less, then smaller amount of force also tries to move that object or will be able to move this object. I hope you are clear about a frictional force also by this examples. Okay, now please write down some work. I have brought some work for you. Okay, like a assignment, okay, which should be done by you. So please write down a little bit fast way, okay, because we are running out of time, because my time is going to be over from here. Today we have learned about the types of force. In these types of force we have seen centripetal force, gravitational force, magnetic force, electrostatic force, and frictional force. I hope you all are clear about it. Now, write the types of the force. Okay, for question number 1, you write down. You should write what type of force is acting on this object. Okay, write the types of force acting on the given statement. You can write over there. An apple which falls on the ground. An apple which falls on the ground. Okay, in bracket you can write earth also, because we are talking about earth. Now give a dash after that. You should write name of force over there. Now question number 2. A center seeking force. A center seeking force for a satellite revolving around the earth. A center seeking force for a satellite revolving around the earth. Give a full stop and give a dash. What kind of force is there? Satellite moves in a circular motion in the earth, okay, around earth. Satellite moves in the circular motion, and there is both force as I talked before. Okay, let's compare with that and write the name of the force. Next, third number. A magnet attracting pieces of iron. A magnet attracting pieces of iron. Give a full stop. After that, give a dash. You should write there the types of force, name of the force. Question number 4. A balloon which attracts another balloon rubbed with hair. When rubbed with hair, give a dash after that. Okay. Question number 5. An opposing force which comes, okay, an opposing force which exists, you can write exist, on moving a large wooden block. On moving a large wooden block. Okay, give a full stop and give a dash. You should write the types of force over there. Okay, now my time for today's is over. Okay, thank you student for listening my class. Thank you for your valuable time. I hope you will read and you will revise something from your book also. You will tally the things which I have told you. You will compare it from your books and try to know and keep learning during this COVID-19 pandemic also. Okay, stay safe, stay healthy at your home. Okay, and thank you for all the small or big hands for generating this program. Okay, thank you very much. Stay safe, stay at your home. Okay, thank you.
भाइ बहिनीहरू, तपाईहरु अहिले कार्यक्रम रेडियो स्कुल सुन्दै हुनुहुन्छ। कक्षा सुनिसकेपछि तपाईका केही प्रश्न वा जिज्ञासा भएमा रेडियो साथीको फोन नम्बर 023 563 037 मा फोन गरेर प्रश्न टिपाउन सक्नुहुनेछ वा हाम्रो फेसबुक पेजमा समेत प्रश्नहरू पठाउन सक्नुहुनेछ। अर्को कक्षामा भाइ बहिनीहरूको जिज्ञासाको समाधान गर्ने प्रयास गरिनेछ। अब आजको अन्तिम कक्षामा कक्षा 9 र 10 का विद्यार्थी भाइ बहिनीहरूका लागि कक्षा सञ्चालन हुँदैछ। कक्षा 9 र 10 का विद्यार्थी भाइ बहिनीहरू कापी कलम लिएर तयार रहनुहोस्।
Hello, a big welcome to all my radio students of Radio 98.6 MHz Radio Sathi from Ishwar Ghimire, Mechinagar 9. This is another Wednesday and your science teacher for secondary level for English medium is back again. Yes students, in past week we learned some chapters of class 9 and 10. Till now we have learned first 2 chapters of class 9 and first chapter of class 10. Today I am going to run the radio class for class 10 and today's topic is the second chapter of class 10, that is pressure. I hope all of you students are near radio set tuning Radio Sathi 98.6 MHz and you are ready for the class to resume with pen and copy. I hope you are with pen and copy. So let's make the day more fruitful and yes, let's get into the topic. Today's topic is pressure. Yes students, first of all, what comes in your mind when you think about pressure, students? Obviously, you have learned in lower class also. Pressure simply means force exerted per unit area. Okay, if you press on any surface by applying some force, then on unit area of that surface, what amount of force is applied? That is simply pressure. You know it already. This is definition for you. Yes. So the formula for pressure is pressure P equals to force upon area. Yes. And you may know already about SI unit of pressure also, it is very simple to you of class 10 students. Simply it is Newton per meter square, because force upon area means force has unit Newton, area has unit meter square. So Newton per meter square, and simply this Newton per meter square can be called as Pascal. Yes, this is called Pascal. So Pascal is the unit of pressure, we can say like this also. If someone asks you about defining 1 Pascal, then how do you define, students? 1 Pascal we can simply define as the pressure exerted by 1 Newton force acting normally over 1 meter square area. Yes, if you apply 1 Newton force on unit meter square area, then it is simply 1 Pascal. Okay, so if you see the relationship between force and pressure and area, pressure and force, what do you find, students? Yes, from the formula we already know, pressure P equals to F by A, means pressure is directly proportional to force. I mean, if you apply more force, there will be more pressure exerted. And another relation, pressure is inversely proportional to area. If you increase the area, pressure will decrease. For fixed force, if you increase the area, pressure will decrease. And if you decrease the area, then pressure will increase. Yes. This common example you can experience easily by many means. Simply, if you think about a girl walking with a slipper, flat slipper, the girl is stepping on another's leg somehow, unknowingly, the person will feel pain. Yeah, obviously the person will feel pain. But if the girl is not with flat slipper, rather with pencil heel, then what happens to that person where she is stepping on? The person will feel more pain. With flat slipper, person feels less pain, but with pencil heel will feel more pain. So what can we understand from here? It is very simple. Flat slipper has more area, so pressure exerted will be less. But pencil heel has less area, so the pressure exerted will be more and the person feels more pain. Yes, we can understand this very clearly. There are so many applications of pressure. Learning about pressure, we have to know about its application also. And many of these applications are very common to us. These are daily life activities. Some examples we can see, like you have seen the foundation of the building is made wider. Yes, when pillar is constructed of the house, if you observe at the bottom of it, there is a flat surface created. The concrete of flat surface is there. It is of wider area. Why? Because the heavy building may produce more pressure there. So to reduce the pressure, area is increased of the bottom of pillar, so the house doesn't sink down later. We know about it. Cutting instruments also are made very sharper. You know, when you cut something with sharper device, then it is so easy to cut. But if it is somehow a bit blunt, then you have experienced what happens. You have to apply more force or not? Yes. If it is sharper one, area is less of the edge of the knife, and you should not apply more force for getting good pressure. Easily you can cut. But if it is blunt, you have to apply more force. Means pressure is not exerted well on bigger area. You know that. Also the needles also and the nails are made sharper. You know about it. Same logic you can tell for this question also. And do you know one thing, students? Okay, I am asking to you. Can you sit on a chair of nail? Can you? You may be thinking what I am asking to you, why I am trying to punish you from here through radio classes. It's not so in fact. In fact, we can sit on a chair of nails. Yes, the nails you have seen around, that nail. How is it possible? Simple thing is there. That is, if you try to sit on a single nail is obviously vertically upward. The sharper part of the nail is facing upward. Yes, you can't sit on a single nail. It will be tough. Why? Because the area of single tip of the nail is very small. Your body exerts more force on the small area of the nail, and there will be more pressure. So you will feel pain. But if you make a chair of many nails facing upward, the tip of the sharper tip of it is facing up and it is making a chair, then you can easily sit on it without any trouble, because there are many nails and the area, the sum of the area of the tips, because there are many tips facing upward. If you see there, you are touching the many nails together while sitting, means you are touching on more area, and pressure exerted will be less. You don't feel more pain, it will be easier. Yes, you have seen heavy loaded vehicles are provided with paired wheels. Yes, you have seen the Lohari and the big trucks are with double wheels together. And if it is very long truck, then you can see like 12, 18 or 24 wheels also. Why is it so? To increase the area. Yes, if it is in pair or there are many wheels together, then the area it is touching on the ground is more, and pressure exerted on the ground on the road will be less. And with the less pressure, it can move ahead easily. If there is more pressure, ground may be sinking down, it will be depressed down. But if it is with more wheels, area is more, pressure will be less, vehicle can move ahead very comfortably for that reason. Yes, and you have seen the football players like Cristiano Ronaldo, Lionel Messi, and many other, the names of big stars. They wear boot, shoes, the boot you can see. If you notice, not only their boot, you can see their boot easily, but around you also many players are playing, or you also may be playing the football. That time the boot you are wearing is with many studs at the sole of it. You have noticed it, yes? Yeah, studs means that many throne like sole is there. Why it is provided with such studs? Because if studs are there, then full flat region, that full sole of it is not touching the ground. Yes, full sole of the boot is not touching the ground, means only the studs are touching on the ground. So the area covered by studs is less, and this stud with more pressure gets into the ground, and grip on the ground will be better. Yes, area of studs is less, studs gets into the soil of the ground, and while running the pressure exerted on the ground is more, so studs gets into the ground and grip will be better, so the players while running won't slip. But if you play with flat sole having shoes, then what happens? Yes, you can slip easily and it will be tough for running. Yeah, you can understand the logic is same for this also. Rear wheels of tractor are made wider, do you know? Yes, if you observe the tractor, the back wheel of the tractor is big and wider. The front wheel is very small, but back wheel is very big. Why? Reason is same, to increase the area so that pressure will be less and it can move on damp area also without sinking down. Yes, without sinking down. After that, we have to learn about liquid pressure in this chapter. Pressure, liquid pressure simply means pressure exerted by liquid. Yes, liquid exerts pressure in all directions, students. Solid doesn't exert pressure in all the directions equally, but liquid has certain property with which it exerts pressure in all directions equally. That is its unique property. And to find the formula for finding liquid pressure, you have learned in lower class also, you have derived also, but in SEE also sometimes it is asked about it. So pressure P equals to, as you know, H into G into D. Yes, H into G into D. Here H refers depth of the liquid column, G refers to acceleration due to gravity, that is 9.8 generally, and D refers the density of the liquid used. Yes, there are some application of liquid pressure. You know that dams, do you know the collection of water is there somewhere, that is called simply dam, reservoir. Dams are made wider at the bottom. Yes, at the bottom part of dam it is made wider. Why? Because we have just learned one formula for pressure. Pressure depends upon depth of the liquid column, acceleration due to gravity, and density of the liquid. Yes, so obviously at the bottom of the dam, the depth will be more down you go, there will be more pressure of the liquid. So the bottom part of the dam experiences more pressure of liquid. To sustain that high pressure, it should be made wider and thicker at the bottom. That's why dams are made wider at the bottom. Yes. So if you see the relation of pressure with density, the depth of the liquid column and acceleration due to gravity, some activities can be performed. From here I can't say everything about activities, it's not so easy to show to you, but still I am giving you some idea, I think you can understand. If you take two balloons, fill one balloon with water and next balloon with mercury. You know mercury, students? Yes, mercury. Then what do you find there? Obviously if you do it, you'll find that the balloon with mercury will expand more. What can you understand from this activity? It is so clear that density of mercury is more, so liquid pressure, I mean the mercury pressure will be more than the water pressure. That's why balloon filled with mercury expands better, I mean more than balloon filled with water. It clearly shows if density increases, liquid pressure also will increase. Yes. Next, to see the relationship of pressure and height, you can do one activity. It is very easy to do. You can perform at home also. If you take a mineral water bottle, yes, mineral water bottle you can take, and make holes on the side of it at different height. Yes, from top to bottom, around 3-4 holes you can make at different height on the side of bottle. Then fill the water fully. Now open the holes and observe what happens. Obviously water comes out, yes, but the waters from different hole will reach to the different distance. It will cover different distance, and if you observe there, you'll find out the water from the bottom hole goes farthest, and water from the hole a bit up doesn't go that much far, and the water from the top hole comes out but goes the least distance far from the bottle. If from the bottom hole it goes 2 meter far, for example, from the next one hole a bit up, from that hole it may go around 1.5 meter only, and from the top hole it may go only 1 meter far from the bottle. So it clearly shows at the bottom the depth of the liquid column is more from the top, and for other holes the depth will decrease. That's why more the depth, more the pressure, that's why liquid is going far. So it is showing liquid pressure increases with depth of liquid column. It is very easy to understand. Some questions can be asked to you in SCE relating to this concept. Question may read out like this: if a hole is there at the bottom of ship, it is more dangerous than the hole at the side of it. Why? If hole is created at the bottom of ship, it is more dangerous than the holes on the side of the ship. Why? It is so clear. Because the depth of the liquid at the bottom is more, so the liquid, I mean the water from the ocean enters to the ship with more pressure from the bottom, and it may be filled faster. There is chance of sinking it faster, and we may be in trouble. That is very simple thing. Next one, or deep sea divers wear safety suit. Why? Yeah, if for some research purpose some people go into the sea, into the ocean for finding something, they can't go without special protection. They have to wear special type of suits before jumping down, before diving down. Why? Reason is clear. Because they have to go to the deeper part of the ocean, and when they go more and more down, the depth of the liquid increases from the top. Yes, they are going more deep, means depth is increasing. When depth increases, the liquid pressure also increases, and they can't sustain that high liquid pressure at the bottom. They may be in trouble. That's why to sustain that high liquid pressure, they are provided with certain types of safety suit. Yes. Another very common question can be asked to you. I'm giving you some idea. I think you are perceiving it well. If you are taking two buckets at the top of the floor of the house and at the bottom floor of the house, if you keep two buckets and start filling the water, what do you think? Which bucket will be filled faster? Yes, the bottom one will be filled faster. Why? Because you know, students, water tank is always kept at the top of the roof, I mean at the top of the building. So the water that is coming down from top of the building for the water going to the bottom floor, the depth of the liquid, I mean the depth of the water is more, and water comes out from the bottom tap with more pressure due to more depth from roof to the bottom. But for the bucket at the top floor, it will be filled very slowly because the depth is no more and pressure also is very less. So water comes out with very less force and it is filled late. Yes. And very simply, I just told you water tank is kept at the top of the roof. This also can be asked why. Because if we keep the water tank at the top, the distribution of water will be easier, because to distribute the water on the lower area will be easy, because due to more pressure water can flow easily and distribution will be more easier. Yes. Now if you see the relationship between pressure and acceleration due to gravity, obviously this also is directly proportional. How can we see this relation? Where can we observe this relation? For that, if you take a water filled bottle from Tara region to Himalayan region, then water coming out from certain hole of the bottle in Tara region will be going far, but in Himalayan region the water can't go that far from the same hole in Himalayan region. Why? Because G value in Tara region is more and G value in Himalayan region is less. As you know, G, that is acceleration due to gravity, is inversely proportional to square of the radius of the earth, and radius on Tara region is less, so G is more. More G means more pressure. Water goes far distance from the bottle, and in Himalayan region R value is more, means value of G will be less. If G is less, then pressure will also be less and water can't go much far. That is simple thing for you. I think you are understanding about pressure. Now if we discuss about pressure more, then in this chapter you can sometimes be asked about the difference between force and pressure also. If that is asked, then simply you can define force and define pressure. That will be one difference. Next difference, you can write the unit. You know, unit of force is Newton, unit of pressure is Pascal. That is another difference. And next also is there, that is if force is vector quantity but pressure is scalar quantity, that is another one. And force is cause of pressure and pressure is effect of force. When you apply force, then there will be pressure. And also the force has the formula, that is F equals to ma, and pressure has formula F upon A. So these are simply differences. You can understand it very well. About when we tell about liquid, we have to tell one thing, that water makes its own level, or simply liquids make their own level. When you pour liquid into certain vessel, then whatever may be the shape of the vessel at the bottom, it doesn't matter, but from the top you find the plane level of it, means liquid makes its own level. We know about that. Now in this chapter there are some important laws we have to discuss about. First is Pascal's law, then we have to learn about law of flotation, and next is Archimedes principle. So these are very important three things here in this chapter. First of all, let's discuss about Pascal's law. Pascal, name of scientist, he gave a law for about liquid pressure. Okay, what it tells is liquid enclosed in a vessel transmits increased pressure equally in all directions. Yes, if you keep liquid inside a vessel, in closed vessel, and you push that vessel from any part of it, then from every part, on every part the pressure experienced will be same. You can simply experience this and you can perform this activity also. If you take a mineral water bottle, okay, that is easy to obtain, so I am giving example of it. If you take mineral water bottle and make some holes on the side of it on the same height, let's make 3-4 holes on the side of mineral water bottle at certain height, at fixed height, and fill water. After that, when you fill water, obviously the water starts to come out from the hole, but if you squeeze the bottle from any part of it, then what happens there? On squeezing, you will find water from every hole will be going far equally. Yes, from any part you can squeeze or you can push the bottle from any part, but the effect will be seen from every hole. From every hole water will go far. Means it shows that pressure applied is transmitted in all direction equally. This is about Pascal's law. Yes, Pascal's law tells that liquid enclosed in a vessel, yes, liquid enclosed in a vessel transmits increased pressure equally in all directions. Yes. There are some applications also of Pascal's law. The applications of Pascal's law we can observe in some devices. These devices are widely used, like hydraulic press, hydraulic brake, hydraulic jacks, and many other also are there. And all the machines mentioned here simply called hydraulic machines. Yes, these all are hydraulic machines. What is hydraulic press? It is simply a device that is used for compression and is a lifting device also in seaports and in industries. Yeah, for lifting purpose or for pressing purpose it is used. Jack also, hydraulic jack, it is used for lifting purpose. Brake is there. Nowadays the vehicles are available with hydraulic brake because it is quite able to stop even bigger vehicles at the waist position. I mean, quickly it can be stopped. It works well. So simply in hydraulic machines liquid is used. Why it is so, students? Why liquid is used in hydraulic machines? Why not other things? Because there are two very important properties of liquids. These properties help using them in hydraulic machines. The properties are: liquid is almost incompressible. Means, can you compress liquid? No, we can't. Can you compress and fill 2 buckets of water in 1 bucket? Can you? If there is shortage of water, can you store water by compressing water in a bucket? No. You can fill only 1 full bucket in 1 bucket. You can do more than that because it is incompressible. And next is, liquid transmits equal pressure in all direction. Yes, it transmits pressure equally in all directions. So when you push on one part of the certain thing like mineral water bottle with water, if you push on one part, then it will be transmitted in all direction equally. That is another property. So it helps to use it in that region. Next, we have to learn about density. Density is not new topic to you students. You have learned already about it, and here we are not learning in detail about it. Simply, density is mass per unit volume. Yes, density is mass upon volume. And generally, density of water at 4 degrees centigrade is, density of water at 4 degrees centigrade is 1000 kg per meter cube. How much, students? 1000 kg per meter cube. And in Celsius unit, it is 1 gram per cm cube. Next is their relative density. Simply, relative density is density of object upon density of water at 4 degree. Yes, density of object upon density of water at 4 degree. This is simply ratio of 2 densities. That's why relative density has no unit. Okay. Next is, we have to learn about upthrust. Simply, upthrust means, as the word suggests, upthrust. Upward pushing force is simply called upthrust. If you keep any object in liquid, the liquid experiences force upward. That is called upthrust. So we can define it like this. Upthrust is defined as the resultant force experienced by an object kept in a liquid. Yes, if you keep an object in liquid, the resultant force experienced by it is called upthrust. Why it experiences force upward? In fact, it experiences force from every side, but from the side the force experienced will be equal, the pressure will be equal. That's why there will be no effect. And top surface is on less depth from the water level, but bottom surface of that object is on the more depth, and as you know, more depth, more pressure. So pressure at the bottom will be more, but pressure at the top surface will be less. So the more pressure will be pushing it up. That's why the object is pushed up. So of thrust acts upward. In this case, in exam we have to derive one relation also. I can't say from here. You can see in book, U equals to VdG. Yes, of thrust equals to volume of immersed part of object or volume displaced by the object, volume of water displaced by the object. Next, density of the liquid and acceleration due to gravity. Yes. So we have seen here there are three factors upon which the upthrust depends. One is density of liquid, another volume of immersed part of an object, and next is acceleration due to gravity. Yes. Another principle is there, students, that is Archimedes principle. Archimedes principle is very important. It tells that when a body is partially or fully immersed in a liquid, yes, when a body is partially or fully immersed in a liquid, it experiences an upthrust which is equal to the weight of the displaced liquid. Yes, it experiences an upthrust which is equal to the weight of the displaced liquid. Yes, if you put any object inside the liquid, then the upward force experienced by the liquid will be equal to the weight of the liquid displaced by that object. Yes, this is Archimedes principle. And if we see about floating body, what type of bodies float on the water? There is one principle of flotation we have to discuss about. Principle of flotation tells that floating body in a liquid displaces the liquid equal to the weight of the object. Yes, if a body is floating, then this body displaces the liquid. When object is put in liquid, then obviously some part of the liquid will be coming out of the can, out of the vessel. That's why a floating body in a liquid displaces the liquid equal to the weight of the body. Yes. And what type of object float on liquid, students? For that, you know, if density of body is more than density of liquid, then simply it will sink. If density of body is equal to the density of liquid, then it is just sinking, or we can say just floating. It is just inside the level of water but not going to the bottom. That is the case. At that point, density of the body and density of the liquid will be same. It is just inside the liquid, means it is also floating case. And next is when density of body is less than density of liquid, you know, it obviously floats. So there are two cases for floating. One, density of body is equal to density of liquid, then it floats. Next, density of body is less than density of liquid, then it floats. Yes, there are two cases. But when density of body is more than liquid, it will sink. Yes. So in floating case, obviously the upthrust is playing the role. Upthrust pushes the object upward. That's why it is floating. Yes. So there are many cases about many questions can be asked about this concept. So you have to see in book, like iron nail sinks in water, but big ships made up of iron won't sink. Why? The reason is simple. Iron nail is very small, not occupying more space. So the density of iron nail is more than density of water in ocean or in water anywhere. It sinks. But if you see the ship, although ship is made up of iron, it has hollow space inside, big hollow space. So overall the effective density of it will be less than the density of, overall the effective density of ship will be less than the density of water, of ocean. That's why it will float. That's the reason. Another concept you can tell, iron nail cannot displace the water of its weight, but hollow ship can displace the water of its weight, so it can float. For floating of any object, it should displace the water of its own weight. Big ship is sinking much part of it and throwing more part of the water out, means displacing more weight of water. That's why it is able to float. So okay students, today we have come to end part of our radio class. We don't have more time for today, we discussed about chapter pressure. You are at home, you are in lockdown time period, so you may be having some trouble, but nowadays the things are getting bit easier. We hope to get it more and more easier, and I hope you are giving time for study. You are tuning into Radio Sathi 98.6 megahertz through radio classes and getting your knowledge enhanced. I hope all of you are getting fruitful time here. For today, this is Ishwar Gimire from Mechinagar 9 signing off for today. Stay home, stay safe. Bye bye.
भाइ बहिनीहरू, आजका लागि सबै कक्षाहरू सम्पन्न भइसकेका छन्। कक्षा सुनिसकेपछि तपाईका केही प्रश्न वा जिज्ञासा भएमा रेडियो साथीको फोन नम्बर 023-563-037 मा फोन गरेर प्रश्न टिपाउन सक्नुहुनेछ वा हाम्रो फेसबुक पेजमा समेत प्रश्नहरू पठाउन सक्नुहुनेछ। अर्को कक्षामा भाइ बहिनीहरूको जिज्ञासाको समाधान गर्ने प्रयास गरिनेछ। भाइ बहिनीहरू, आजलाई कार्यक्रम रेडियो स्कुल यति नै। तपाईहरू यी सबै कक्षाहरूको अडियो हाम्रो फेसबुक टाइमलाइनमा गएर दोहोर्याई सुनेर थप प्रष्ट हुन सक्नुहुनेछ। भोलिको कक्षामा पुनः हाम्रो भेट हुनेछ। लकडाउनको बेला घरमै बसी कार्यक्रम सुनेर अभ्यास गर्दै पढ्दै गर्नुहोला है त। तबसम्मका लागि सबै विषय शिक्षकहरूको साथमा प्राविधिक साथी करिना पौडेलसँगै म जिआर धिताल पनि बिदा हुन्छु। नमस्कार।